Voyager 1, the legendary spacecraft launched in 1977, has defied every conceivable limitation of human engineering. For nearly 5 decades, it has been hurtling through the cold, silent void of interstellar space and has once again stunned scientists and space enthusiasts with its latest unimaginable discovery. The discovery was not only unexpected, but also calls into question existing theories about what lies beyond our solar system. This new interaction occurred so far from Earth that the signals sent back take almost 22 hours to travel over 15 billion miles of black emptiness. And yet, there, in that distant space, Voyager 1 found something. Before we continue, don't forget to like and subscribe to our channel for new updates. What makes this encounter truly remarkable is not only its location, but what it represents: the first detection of a highly organized interstellar phenomenon in dynamic motion. This is not just a region of dust or radiation. It is something that moves, reacts, and emits structured signals that the Voyager instruments are barely able to interpret. For years, scientists had expected a quiet journey through interstellar space. They predicted fluctuations in cosmic rays, changes in magnetic fields, and possibly shifts in particle density. But this region, saturated with unpredictable energy and magnetic complexity, was beyond all models. As Voyager 1 approached this area, its magnetometer and plasma wave detector began to record unusual signals. The steady rhythm of interstellar particles was replaced by sharp gradients and pulses. Its cosmic ray system, which normally records a stable level of radiation outside the heliosphere, suddenly detected patterned fluctuations, as if something large and organized was influencing the flow of charged particles. These were not simple anomalies. They were imprints of structures. Huge, invisible structures consisting not of matter, but of magnetic fields and waves stretching for light years. For a long time, interstellar space was considered virtually empty. Voyager 1 crossed the heliopause in 2012, entering what was thought to be a boring space filled with sparse hydrogen and cosmic rays. But where it is now is far from empty. The data points to a complex plasma environment, possibly formed by the remnants of ancient supernovae or curved interstellar magnetic fields. Even more mysterious is that this structure interacts with Voyager itself. Despite the absence of an active engine, some instruments began to show feedback, as if the spacecraft had passed through a resonant field. The implications of this discovery are enormous. It changes our understanding of how space is structured beyond the heliosphere. If Voyager 1 has discovered one of the interstellar corridors or magnetic streams, then such structures are not unique. Perhaps the galaxy is riddled with such regions created by forces we do not yet understand. They could be particle acceleration channels, cosmic ray conduits, or even natural boundaries between regions of interstellar space. Space is not just a vacuum with stars, but a living, evolving environment full of patterns and structures that contradict existing astrophysical models. The data also indicate that these regions may have local conditions, almost like a microclimate on a galactic scale. Voyager 1 recorded a sharp drop and then a surge in cosmic rays, as if it had passed through a magnetic bubble, an area where external radiation was shielded or distorted. Such behavior has never been recorded in real time before. Scientists hypothesize that Voyager 1 may have passed through several such zones in succession, hinting at a layered structure of the interstellar medium, similar to geological layers on Earth. These zones may contain crucial information about the life cycles of stars, the migration of interstellar clouds, and the dynamics of the entire Milky Way galaxy. And although the instruments on board Voyager are long outdated, they continue to provide invaluable data. These are not the latest cameras and supercomputers, but old analog sensors that record magnetic fields, plasma density, and particle flow. It is almost poetic that the technologies of the past are helping us to glimpse the ancient structures of the universe. One of the most striking discoveries has been directional plasma waves that are not background noise. They propagate along specific vectors, possibly echoing ancient supernova explosions that have reached us thousands of years later. This confirms the idea that interstellar space is more like an ocean than a void. It carries the echoes of ancient violence across infinite distances. The waves also oscillate at a regular frequency, hinting at a resonance effect. It is as if Voyager has entered an invisible chamber where waves reflect and interact. This changes the very essence of the scientific approach to the structure of the galaxy. Perhaps space consists of rooms, where energy and matter behave according to their own laws, determined by the orientation and intensity of magnetic fields. However, this discovery raises questions that modern missions cannot answer. Voyager 1 is alone, and there is no other spacecraft capable of exploring this space in the near future. This data may remain a unique moment, a photograph of an alien environment that we will not be able to explore again for decades. Nevertheless, even a single glance is enough to understand that the boundary of the solar system is not a threshold into emptiness, but a door to something alive and dynamic. Another observation concerns the interaction of charged particles in this strange environment. Unlike the solar wind, the particles here seem to be twisted by invisible vortices, their flow structured as if guided by an unknown force. These patterns may tell us about the processing of matter and energy by galaxies over billions of years. The particles recorded by Voyager may be older than the Sun itself. Their path has been twisted for centuries until they came into the field of view of a probe launched from the blue planet in the distant past. This raises the question, what else might be hidden in these interstellar depths? If waves and fields can form such structures, what else might they conceal? Could these regions attract interstellar dust, ice, or even wandering planets? There is a hypothesis that Voyager 1 is flying through a crib of matter, not the kind that creates stars, but the kind that preserves the debris of cosmic history. Equally exciting is how this discovery reflects on our own planet. The more we learn about the interstellar environment, the clearer it becomes that our solar system is not in a vacuum, but in a turbulent, living ocean. The boundary separating us from outer space is not a clear line, but a turbulent layer filled with energy and structure. The knowledge that there are active zones beyond the solar system changes not only science, but also the philosophy of space exploration. Voyager 1, in its silent odyssey, has shown that the space between the stars is not an empty bridge, but a full-fledged territory full of history, structure, and energy. This moment, this encounter, confirms that the decision to launch Voyager 1 was the right one. This discovery proves that the greatest mysteries of the universe are not always hidden in the bright light of galaxies or burning stars. Sometimes they live in the cold silence between them, in ancient vibrations pulsing through magnetic rivers, in the tranquility where a tiny device from Earth has just touched the impossible. If you like this video, please like and subscribe to our channel. Also, write in the comments what you think about Voyager 1's new discovery after all these years in space. Your opinion is important to us. See you next time.